looks like this should be working, I believe. So if somebody wants to let me know in Slack if you can see and hear all right and stuff like that, that would be good. So maybe I'll hang on for a second and just say, okay, let's see, hold on. It does appear to be working because I had the stream open and started hearing myself, what I was saying maybe 15-20 seconds ago. So yeah, it looks like this should be up and working. I don't know who all is here yet, but yeah, so this is the live stream for Geo-Python for week 7, I guess, for lesson number 7, and an exercise 7 about plotting stuff in Python. And I think my plan was basically to kind of go over a few basic things about creating plots in Python, and we'll focus on this Matplotlib plotting library because that's the one that's been introduced in the lessons for the course, but also is probably the most common and easiest to use from the perspective that you can find good examples online of all of these different kinds of plots with the Matplotlib library. So I'm still waiting to see a confirmation that this is working properly for everybody, but I guess well, I hope that's the case. So what I'm gonna do just to get started is maybe take a look at some simple examples that are based on exercise number, or problem number 1 from exercise 7. And that is this idea of making a kind of simple scatter plot. I guess there was a question about this that I saw in Slack about the colors of some of the points when you make these kind of scatter plots, and why maybe you were getting different colors than what was shown in the figure on the course webpage. And so that's a place to get started, I guess. It looks like, yay, the stream is working. Okay, so that's good to have confirmation. So we'll start here. I'm just going to make a quick markdown cell for this with plotting some random points, not points, but points with random colors. So this is basically problem 1. Of exercise 7. So the idea here is that what we want to do is generate a scatter plot from random points, and we can define our random points using this NumPy library to generate a list of random numbers, and we want to color them, and we're going to use a scatter plot to do this. So to get started with this, first we need to load the modules we need. So in this case, we're going to need to import NumPy as NP. We're going to import matplotlib.pyplot as PLT. So again, just using the shorthand names for these. And actually, while I'm in here, I'm just going to import pandas as well, just because we may come back to using that at some point. So these are what we're going to need just to be able to get started as the modules. So NumPy, pandas, and the pyplot part of Matplotlib. That's the common part of the plotting library that we would be using. And once we have that, then our job, I think, was to plot something like 1,000 random points. So we need to fill in some arrays with these random points for X and Y coordinate of where each point should be located, and also a random color. And so let's make some random points. And we can do this by making first an array called X. And we're going to fill in random numbers here using the np.random.rand function. And we're going to do this for 1,000 points in the X direction. And the same thing goes for the Y direction. I'm just going to copy and paste this because we want a random 1,000 points in the Y direction. And I'm also going to make random numbers for the colors that we're going to use for each of these points. So what this will do is give us 1,000 random numbers between 0 and 1 in the X array, 1,000 random numbers between 0 and 1 for Y, and same thing for the colors. And if we run that, then we'll define those three things, those three different arrays of random values. And the next step then is basically just to plot the results. And for this, we can use the plt.scatter. It's one of the plotting options. In fact, I'll show you what some of the other ones look like in just a second, and what the kind of pros and cons are for this. But let's make our colorful scatter plot. So we're going to do plt.scatter. That's how we can create a scatter plot, and we'll say x is equal to x, y is equal to y. So those are the values that we want to use for the x and y coordinates of each point. And then I think we can just say c equals colors in this case. So c is shorthand here for the color that those points should be colored with. And if I run this cell, I get something that looks like this. And perhaps this comes to the question that was asked in Slack, or mentioned at least by one of the instructors in Slack, about the coloring of the points. And you notice here that these color points are, well, first off, they're not showing any kind of red tones at all. There's no reds, there's no orange, there's nothing like that. It's only blue, green, and yellow. That's not a problem, actually. That's kind of what's expected, and I can say something about that in just a second. I'm going to, before I say something about that, I'm going to go here and add an extra cell. And this extra cell is so that I can make the plot a little bit bigger. I'm going to just put in a command that will make the plot size a bit bigger, and hopefully it's a bit easier to see that way, because I think I have not zoomed in or anything. What I need to do, though, to do this is I'm just going to go to the lesson and find the section about making the plot bigger, because I can never remember what this command is to make the plot size bigger. So I'm just copying and pasting this from the lesson, this plt.rc params thing. We'll make it so that the figure equivalent size is 12 inches by 6 inches, because of course inches, since this is coming from some developers in the US. So if I run this scatter plot command again, now I get a bit bigger plot, more space between the points and things like that. So about the colors here, yes, they are different than what was shown on the course webpage, and that has to do with a change in the default color bar that's used for making plots in Matplotlib. I think it was starting sometime back, even around the time that Matplotlib 2 was being developed, or maybe it was the transition to 3. But somewhere in there, the default color changed, and it used to be this thing called Jet that looked nice in some sense. I'm just going to go here and say Matplotlib color maps, because I think that's what those things are called. And so here we have choosing color maps in Matplotlib. You can go and Google the same thing and find this article. And if we scroll down, you'll see a whole bunch of different color map options. We can specify those if we want to when we make a plot to change what range of colors are used. But what I want to highlight here is this jet that's down here in the miscellaneous color maps. That was the default before. And so jet went from this kind of dark blue, very kind of saturated dark blue through basically the whole rainbow to a very dark red. Now, visually, to people who have no problems with color blindness, that looks like a nice range of colors. But if you have issues with certain colors, this jet actually doesn't work very nicely because some colors appear to be quite similar and are not able to sort of distinguish between the two. So, it could be that there's reds and greens that are kind of problematic in this color range. Now, what that means is that the default color map has changed, and it's now, instead of jet, it's this thing called Viridis. That's what's called a perceptually uniform color map. And in this case, the idea is that actually, if you're someone who has difficulties with color blindness, that you can basically distinguish between all of these colors in this color map, regardless of your kind of visual capabilities. So it actually works even as far as if you print something in grayscale using this Viridis color scheme, it actually transitions quite nicely to grayscale. So there's no kind of problems of like printing something out and not being able to see the colors. But that's the reason why things look different. Previously, the default was this jet that included reds, and now the default color map in Matplotlib is Viridis. I think we can change that. I'm going to kind of go out on a limb here, and let's say we want to change it to something like magma, since we're geoscientists, and that sounds exciting. I think if we add just one extra keyword argument here, we can say cmap, not camp, cmap equals, and if we put in quotation marks here, magma, and run the same thing, yeah, we can change the color map that way. So if you, for instance, wanted to reproduce the plot from before, where you had these kind of candy points or whatever it was called, you could change that CMap instead of magma to be jet. And if you run that, then you get the same kind of colors that you had before that look much more like, I don't know, confetti or something like that, or sprinkles that would go like on a cake. So anyway, in this example, I guess the kind of positioning of the points is clear from the random x and y values. The colors being random numbers, what will happen in the scatter plot by default is that it will just take whatever the minimum color is and use that as like the lowest end of the color map. And the maximum value in the range of colors would be the maximum on the color map. So, these points that are blue are going to be close to 0 for the number that was assigned there. And the points that are red in this instance would be close to having a value of 1 in their random numbers. So it just distributes then all these colors based on the number that's in the colors column from 0 to 1 in this case, because we've just filled it with random numbers from the NumPy random function. So yeah, so that's plt.scatter, and the reason why we use that particular plotting command here in this instance to get the colorful plot like this is because there are alternative plotting possibilities, but not one that really provides the functionality of having different colored points. So for instance, you might think that you could just use the plt.plot with x equals x, y equals y. But in plt.plot, I don't believe there's a possibility to specify the color of the points that get plotted in the plot. And if we try to say something like c equals colors and run this, we're going to get some kind of bad news here. We didn't actually get an error message, which surprises me a bit. But okay, it seems to be unhappy about something else. Maybe it just needs to be that we're not specifying keywords. Okay, so if we do plt.plot just x, y, we get this like hairball. And I think there basically is nothing where we can assign colors to the points because it's not supported in the plot function by default. It's supposed to be the kind of fast way to plot your data, So plt.plot is the kind of usually the first thing that we learn. I think it's the first thing we covered in the lesson about Matplotlib in general. And when you come in here, then the default is that you're going to have some kind of blue colored lines that are connecting all of these points, X and Y. And because they go in order, you know, that you get this kind of nasty mess here because the random points are just going all over the plot. If we wanted to at least get a step closer to what we have here, we can add in some of this basic formatting. So with plt.plot, there's kind of a shorthand thing. So that if you put an O in here, in quotation marks, it will plot as little circles. And we can run the same plot command. And you can see actually that the positions of the points are the same. So you can see like here, there's a nice little cluster of points and then one over by itself. You see the same thing here in the lower plot, the cluster of points and the one over there by itself. So the X and Y coordinates of the points are exactly the same as they were before, but the plt.plot command doesn't give you the option of coloring the points when you've plotted them. You can change the color of all of the points. So for instance, if we add in here another little shorthand thing like an RO, that will give us red points or red circles. And so you could do things like that, or you could do KO for black, because, you know, of course. And there are other things like, you know, let's say instead you wanted black points, you could have black dots. So if you put a period there instead of an O, you get just little dots instead of circles. And there are other possibilities as well. I think if you do an S, for instance, you'll get squares. So there are several kind of possibilities for the shorthand notation here in Matplotlib's plotting option. Now I think one other thing I could maybe show you here, if you're just curious, is instead of specifying the color in here, you can use this shorthand notation thing. It normally would be that you give the X and Y values that you're going to plot first, followed by the shorthand, and then any optional things would come after that. If you wanted to say the color was something different, you can, and you could say that the color is green. I believe this is one of the options that would work. And this should still plot with squares, but it'll give us a green color for the squares, and yep, there you go. So this is one possibility. In fact, I think there are other colors in here, like gray, that don't have a shorthand. So I think if you put a GS in here, you could get the green points, but I don't believe there's a gray color option there. So if you're looking for certain colors, you have to use this color keyword to specify those. And if you want to get really into details, like you say, well, I want to pick my own shade of blue, you can actually specify here the hex code of the colors. And if this doesn't mean anything to you, don't worry about that. If you want to go look up hex colors, you can Google that and you'll find lots of different options there. But you know, often for myself, I like to use somewhat pastel colors rather than full blue. So if a full blue would normally be the hex value is 0000FF. So there's two numbers here for the red, the green, and the blue components of the color. And if I plot it like this, I get these full blue. For me, I find that full blue is often a little bit too strong. So I'll add a little bit of color in here, like 6666FF, which will then make the blue a little bit more pastel. And I kind of like that appearance of that. It looks like I forgot to close my email. And likewise, you know, you can then do pastel red, for instance, like this. And if you like to pick your colors, you can go online and look for hex colors and find all different kinds of color options that you could possibly use for making plots. I think to change the marker symbols, I think it is the keyword is marker, and again you can set that to be circles. So I'm going to get rid of this S now, go back to, oh nope, it doesn't like that. Could not convert string to float. Maybe I'm specifying the wrong keyword. I pulled up the documentation for this Matplotlib plot function in anticipation that I would do things wrong, and here we go. So maybe it's marker is not the right argument that I'm supposed to give. There's a whole bunch of them here, so I'm just scrolling through. I just did a Google for Matplotlib plot, and this is the first thing that comes up. So if I click on marker, it says I should be able to choose a marker style, and if I click on that, I have all the different options here. Okay, it actually looks like I'm supposed to use one of these kind of shorthand things in here instead of specifying the word circle. So if I go back and just say that my marker is instead of the word circle, just O. Is it happy now? It's happy now. So, but things look kind of nasty because now I have also, I've changed the marker to be a circle, which actually is the default value anyway, but the lines are still here. So, you know, I would need to potentially, or would want to get rid of those, the lines, and I think, you know, if you go back here to the documentation for the Matplotlib plotting function and scroll up to the top, I think there's also something where I could either set the line style to be nothing. So if I just put some empty quotation marks, I can get rid of my line style that way. So line style equals empty quotation marks. Should give us still the circle, kind of pastel red circles, but no lines connecting the points. And we're kind of back to how things looked before. And if you wanted to, you know, you can, I think, put a dot there, and or maybe it's a double dot. Or, all right. Maybe I'm screwing things up here. The point is, you can go to the documentation if you want to do something more sophisticated. Okay, yeah, it looks like it's dotted. It's actually a colon, not a pair of dots. So for the line style equals colon, then I can get this really nasty looking thing with these dots connecting all the points. So if you want to do that, of course, you know, you're free to play around with the formatting. And if you go and look in the Matplotlib documentation, it's not always, I find, the kind of easiest thing to read. I mean, first off, a lot of these things are quite long, and there's many, many different options. But I think the way for me to do it normally would be like I'd have some starter plot that I'm interested in, and then just start copying some of these keywords in and playing around with them, and seeing, you know, if I get the kind of effects that I want. You know, there's, I think, also marker size, something we could specify. I don't remember if it's marker underscore size. This is what's annoying. It's not. It's marker size, all one word. So now we've got big pastel red dots with dashed or dotted lines in between them. So you can play around with this stuff. You know, and if you wanted to get rid of the marker completely, you know, again, you can get rid of that and now just have the dashed lines. Or put in, you know, I think, I don't remember what D is, big diamonds or something like that. Or you can make them really small. I mean, you can kind of do whatever you want in terms of the formatting here. The point is that this plt.plot is very flexible. If you want to plot points that are all the same color with different symbols and things like that, it's easy to use for that. If you want to have points with lines connecting the points, plt.plot's also good for that, because plt.scatter is really meant to be used for like scattered points that are not necessarily connected with a line. In fact, I don't believe there is an option to include a line connecting the points with the plt.scatter function. Its advantage is that you can color the points. So, you know, whether you're making a candy plot or whether you want to use the color to represent, you know, something about your geological data set, age, or something like that, plt.scatter is better for that purpose. And plt.plot then is kind of more flexible if you want to make line plots and things like that. I think those are some of the things I wanted to cover about the basic plotting stuff. So I'll add maybe just a cell here. And just say that plt.plot can be used as an alternative to plt.scatter, but you can't change the marker colors individually. So you can change them for all the points, but not for individual points. So that's kind of an important thing just to have in mind. Okay, so what else can we do here? Well, why don't we load in a data file and we can maybe play around a little bit with plotting there. Are there questions maybe from people in Slack or other things that you want to see about this kind of basic plotting? Is there anything that's kind of confusing about this, or should we go to some examples that might be a little bit more complicated? I'm just going to pause for just a second. Because I think the next thing I could maybe talk about just a little bit would be using subplots. I'm just looking here at the exercise, and I think this is kind of a big part of exercise 7 was this kind of subplots and things like this, making these kind of seasonal plots, and then of course making this nice animation that that you end up making at the end. But I think we can talk about using subplots first, just to cover that, because I think it's useful, and also yeah, basic plotting seems quite straightforward. Okay. Yeah, I think that's the case in general. So that's good. And yeah, I mean, we could talk about using subplots, or you know, some of the other kind of plotting options I think are not necessarily so so challenging. Adding, you know, axis labels and things like this, I think are things that are fairly, I would say, fairly straightforward. But if we want to sort of split our data onto separate plots, maybe that's good. Or the animated plot would be another possibility. Yeah, we could talk about that because that was it was optional in the exercise. Okay, that's that. Then maybe that's something good to talk about. I couldn't remember whether that was an optional thing, or was there, what was this problem number 6? It would have been good for me to review this a little bit more before we got started, because I'm just not quite sure. Okay, so this is creating a Gif animation from the figures. Yeah. So I guess what you guys ended up doing was producing a bunch of figures and then having to make an animation out of those. Yeah, we could do this. This is actually, so for me, this is not the way that I would create the animation. It's a Python way to do it, which is good because we don't have to leave Python to do it. But we need to probably proceed with a few steps before that, about like making a bar plot with seasonal temperature anomalies and things like this. And I'm trying to remember whether or not we have. It was said in the hints for exercise 7 that it was optional. Okay, All right. So yeah, I think we can do this. Do you want to do, I guess maybe the pandas version of the exercise is a bit better for this particular instance. If we want to look at making the animation using pandas, then I'm going to go to the pandas version of the exercise 7, problem 3 through 5. And in the meantime, I'm just going to pull up something on the other screen. Let's see if I can do that. I think I have all the stuff ready to be able to do this kind of plot. So yeah, what I'm going to have to do is kind of quickly go through the parts of this exercise to be able to deal with it. And so let me go here then to exercise 7P. And I think this should be the problem. Problem number 3. And yeah, so first we've got to load in our data file, which we have, and we'll do that quickly using the pandas data reader. So we're going to say data equals, actually I guess I probably somewhere here need to import pandas before I do that. So let's import pandas. And then we can say our data equals pd.read CSV. Oops, read CSV. And then we give our file path. In this case, it's going to be data / what is this thing called? Helsinki.csv. There we go. And I got to put this in quotation marks. And I probably have to skip some rows as well. Maybe not. Maybe this is all set to go. Okay, so I'm importing pandas and then reading in this data file like you would have done, and then these tests should work. These tests don't work. Why is that? Name selection is not defined. Oh, create a variable selection and store the data into it. Okay. For the months. Okay, yeah. So I've loaded the data file. I did not add my selection here. So my selection is going to be from my data file, values that are in locations where the date, I guess I've got date M here. So data date _M. So where those values are greater than or equal to, so let's go with greater than or equal to 1953, January 1st, or first month, I guess, in January. And it actually looks like I'm going to have 2 conditions here. So go ahead and throw some parentheses around this. So that's condition 1, is that the data I want is between 1953 January and I guess it's going to be less than something else. Data date _M is less than or equal to 2016 December. And I should have a quotation mark here, not over here. Okay, so then I need some parentheses around this, and that should give me my selection, which is going to include only locations where the date is between 1953 January and December of 2016. Yes, I think that should work. And now my selection.head works just fine. I can see here in the original case I started in 1952, then I've got 1953. Okay, then I've got to have some variables to split off some different months and deal with those. So I need winter, spring, summer, and fall, as would be expected for the different seasons. And well, we could do something quite similar for that. We'll do out of our selection now at locations where selection, I guess we're looking at month in this case, because here you can see in our head we've got a number for the different months. And what we want to say is our month is a month that is in the winter time. So we're going to use the .isIn thing in pandas, and then give a list of months to isIn. So isIn would expect then to have something here, either a single value or a list, and here we want winter, so it's going to be January, February, or December. And I guess we're going to go ahead and make a copy of this so that we're not referencing selection itself, but we're actually copying this to a separate data frame. And we can actually copy this thing here, and just to speed things up a little bit, since I guess you guys have all done this, I'll try and work a little bit more quickly. Let's say winter, spring, summer, and fall. And I'm just going to give these month numbers here. So this should be 3, 4, 5 for March, April, and May, and then June, July, August, and then finally September, October, and November for the fall. So we're just splitting our months up simply. We're not worrying about the fact that like this isn't exactly the seasons, and there's some other issues here too, but we're just going to divide up different seasons and do this quickly so that we can run these print statements here, and we can see, for instance, here that we've got example data from 1952 from winter in quotation marks. Okay, this is not really the winter of 1952, or 1953 rather, because properly that should probably be 1953 or to December of 1952 plus January of 1953 and February of 1953, but that's good enough for our purposes. Okay, so we've got this then, and now we're going to create some additional data frames, it looks like, where we're going to maybe calculate some temperature anomalies. And again, I'm going to do this a little bit quickly, kind of assuming that you've done this part. Unfortunately, to get to the part where we make the any kind of animation or something like that, we have to do these steps first, and I don't have the solutions kind of readily available. So I'm just going to then quickly do this stuff. Actually this next step looks like it's kind of going to be a bit more involved, because we're splitting things off into the different columns and calculating averages. And maybe what I'm going to do is I'm going to quickly copy and paste this because I've got I'm not working on the version of the exercise with the solutions, but I have a copy of that available. Is this going to work? I'm just going to copy and paste it and assume it works because I don't have time at the moment to go through what's happening in the pandas version of the exercise and try to process it all. But I'm just going to run that cell, and now we've got some temperature anomalies here. You guys would have generated the same thing, and I don't really want to spend the time to go through that in any detail. So next would come the stage where we would make this kind of 4-panel plot, which we're going to skip over in lieu of making something that is more like this temperature anomaly animation. And the way that we're going to do this is that basically we're going to create a loop and go over all of the seasons and make little bar plots about for each season, so that we can produce a whole bunch of plots. This also gets to be a little bit complicated, but I think first off, if I just copy the example of the code from the solution that we have that works, I think I'll just maybe paste that in here, and then we can talk about what is going on. So in order to do this animation, basically we want to produce a bar plot. And in each one of these cases, for each one of the years, we want to have the bar plot show us the size of the bar representing the deviation from the average temperature for that season over whatever the reference period was. I think it was 1952 to 1980 or something like that. And once a year, we want to update that to show what the current anomalies are. Okay, you can see here, for instance, missing data from the late 60s, early 70s. And then these different colored bars, in fact, not only are we seeing different colors, but we're also seeing in them a different size of the bar and the color kind of connected to show us clearly where we've got the biggest temperature anomalies with respect to whatever seasons. We want to make this kind of animated GIF like this. That's ultimately what the point is here. We're going to start by defining the years that we want to go over. And here, if you remember, we had data that started in January of 1953 and went through December of 2016. Our stop year in this case then can be listed as 2017, because when you use the range function here, you're going to start with 1953 and you're going to go up to but not include 2017. So we're going to loop over all of these years, and each year we're going to load in some value for what should be plotted on the bar, and then make the plot, save the plot, and then move on to the next year and update things. So here, each one of these, in the first step, each season we're going to calculate what the mean anomaly is for that that season. I believe that's the case here. Yeah, so for each year, so we go and look at the if the value for year in the pandas data frame for the aggregated winter temperatures, if it's equal to the year in the loop, so first time through here, we check to see is the year in our pandas data frame equal to 1953. And then in that year, we then take the value of the mean anomaly for that year. So this is stuff we calculated actually. If I scroll back up here to the last thing that we were doing, we had calculated these mean anomalies for each one of the seasons. So like here was the winter. So when we printed out winterag.head, it gave us the first 5 years of data that we have with the anomaly in temperature for that season. So we have this data already. It's just called mean anomaly for each one of these data frames for winter, spring, summer, and fall. So we're just going to loop over all the years like I mentioned. Define a variable called wi in this case, which is just kind of a short place to store the mean anomaly for that year. So for the winter of 1953, in the first case, we'll just store that as wi here the first time through. And same thing for SP, SU, and FA. Those are just shorthand. So that we can then create something here that's a list of the different anomalies for the winter, spring, summer, and fall for whatever year we're dealing with. Then, like before, we'll create a plot. In this case, we use the plt.subplots, even though we're not creating anything more than one. But we're just creating our plots in that way. And then there's a little bit of tricky stuff that happens in here. And this has to do basically with determining which color should be used for the different, each one of the bars. So for each one of the seasons, essentially what we do is just check to see, okay, is the temperature value less than or equal to 2? Is it less than or equal to 3? And then otherwise, it gets this color. If the season is greater than 0, if the season is less than -3, I guess it's going to get something different in that case. Yeah. You can look through this, I guess, yourself a bit if you're interested. But the point here is basically just to check, if the season's greater than or equal to 0, then you're getting these tests here, and otherwise you're checking the same things here. You're just checking to see if the temperatures are different. In fact, what this is really doing is it's just checking to see if the temperature anomaly, it's taking the value from the seasons list. Remember the seasons list that we created here, in this case, just has an anomaly temperature for winter, spring, summer, and fall. So there's just 4 temperatures in there. And it's just checking to say, is the anomaly positive? Okay. Then is the anomaly less than 2? Is the anomaly less than 3? Or otherwise, it's this color. So we know here that it's a positive number. And this is just essentially associating some color with that, so that when we make the bar plot, we have different color bars for different size anomalies. Same thing happens here just for negative temperatures. So these colors are just picked based on what would look nice for the bars. Then you create the bar plot itself. So that's pretty easy. All we do is just do a bar plot of index, comma, season. Index in this case just comes from the fact that we're using this enumerate function. It causes a little bit of confusion, but essentially it just gives you the index value for each one of the values in the seasons list. So there are other ways you could do this, but that works. And then color equals color. Remember, we're going through here for each season. So now you're making a bar for each one of the seasons. So for instance, for spring, you're might be assigning that season at that point, and you're picking the color that you've determined up here, and the width is set to be equal to 1. Then set the y limits to be from -6 to +6. The reason for this, if we go back to the animation, wherever that might be, I guess I was looking at it off screen before, but the animation in the exercise, if we scroll down to that, in order to not have things jumping all over the place in terms of the range of temperatures, we just choose to have the maximum temperature be +6 and the minimum temperature be -6, which fits all of the data we want to plot in this particular instance, and keeps the the y-axis from changing for each year. Because otherwise, if you allowed it to vary, then what Matplotlib will do is typically try to find a range of values for the y-axis that enclose the range of values for the data, but that could be much smaller for certain years than others. Then, of course, that would get painful to look at. So we set the y limits manually. Also turn off the x ticks, because there's really no meaning to them. They are for the different seasons, but I think that's handled elsewhere, because you put some text up here at the top for winter, spring, summer, and fall. So we don't need x ticks, and then here is where that text annotation for each season is then added. So at the location 0, 1, 2, and 3. So this is how you can position the X value for where the text would be plotted, because the enumerate function gave us the index values of 0, 1, 2, and 3 for winter, spring, summer, fall. And so we know that, and then the y-pos is here set to be 5.5, so it's just up at the top of the range of temperature anomalies. And then, you know, why not just call this winter, spring, summer, and fall. Oops, not fall, but fall. And, you know, I guess there's probably space to squeeze that in there. Otherwise, you add some text labels, and here you specify that the file path should vary. There's a few different ways in which you could do this. I can see the one example here is not the way I would have done it. What's new? I mean, this is something with Python that you always have different ways to do things. I would probably have done out fp equals figures slash seasonal temperature anomalies. Underscore, and I would just do here. Oops. .png. I would just use the dot format option. Since it's a string, then I can easily put the year in like this. This is an old style of doing the Python string formatting, but basically figures, seasonal temperature anomalies, and then in place of this 0 is going to go the year.png, and then to save the figure and then close it. Now this is going to be running, I think, in this directory here. So I might need to create a directory for this for these figures. So I'm going to make an untitled folder here and see if I can't rename that as figures. And then we'll try to run the code. And we'll see if this, whoops, PLT is not defined. Well, I suppose that's going to happen if I haven't imported Matplotlib. So, yeah, let's just import matplotlib.pyplot as PLT up here. So just up at the very top, scroll back down to where we are and run our cell. So nothing's happening in terms of what we see, but the code's running. And if the solution for pandas that was available to me is correct, we should see in this figures directory that we're getting seasonal temperature plots. And we can even go as far as maybe taking a look here to see the names of the, or sorry, the numbers rather, of the years for each one of those plots. And there they are, 1953 so far, now up to 1998. And if I look at, you know, clicking on any individual one of these, okay, I've got some pretty high resolution figure here that doesn't really render very nicely in JupyterLab, but it's there. And there we go, all the way through 2016. I've got all the figures at this stage here from 1953 to 2016. Now in the exercise there is a way to also do the animation of those figures, and I've not included that here. It involves installing a library that I don't think I have installed right now on in Python, but I'm going to use something else just to quickly show it to you since we're running out of time. There's a program called ImageJ. I think it's available basically for any operating system, so Mac, Windows, whatever. And with ImageJ, you can import what's called an image sequence. So I'm going to go here and do that. It's, I think I'm working in desktop, Geo-Python. I guess this is this exercise here. So I choose a directory, basically it contains a bunch of image files, and here I hit open. And then, okay, it sees that there's 64 image files, blah, blah, blah. And here's how much memory it's going to take. So I'm going to hit OK and let this start loading it in. ImageJ is an easy way to create animations from a sequence of images. So whether you want to make an animated GIF or some other format, you can do that in ImageJ, and that's often what I use. You can do it also in Python. But at least for me, I don't know. I just don't tend to do it that way. There's no real reason for that. In ImageJ, once I've loaded the image sequence, I can hit the play button down here. And now you should see basically the same thing as what we were seeing in the animation on the course page. And that is that all we're doing is loading in this stack of images, and each one has a different year listed down here at the bottom for the temperature anomalies for that year. So, you know, if you've done that, for instance, using ImageJ, then at that stage, the next thing to do is file save as. There are several options here. If you want to save it as a GIF, if you want to save it as whatever. I guess there's also AVI if you want to save as that type of animation. Let's see if I save this as a GIF. I'll just call it figures.gif. That's fine. If I go here to my directory where I'm working, so desktop, Geo-Python, exercise 7p, figures, here's my GIF. If I double click on this, okay, it's not showing me the animated version because preview on the Mac is loading in the whole sequence of images, but basically you see that here. In fact, I think if I took that same GIF and said open with Firefox, now I do see the animated GIF. So something doesn't quite look right, but maybe I have been a bit impatient here. Is the ImageJ possibly still saving? I don't know what happened there. Well, I don't know what I did. Maybe I cut it off before it was finished saving. Or maybe it's still working. Oops, it's still writing. Okay, so that's why that didn't work quite as expected. All right, jumping back here, are there any questions? I definitely raced through that stuff, probably faster than I should have. But yeah, I don't know. I didn't really have time to go through all the details and to kind of write the code out the way in which I would have liked to have done, in part because it just would have taken a bit longer. But maybe that was useful in some sense just to kind of see the logic behind this animation, that, you know, this is one way in which you can do it, which is just to loop over the years and then take that data and use that to produce a bar plot for each year, save the bar plots, and then load the whole sequence, in this case into ImageJ, or you can use this ImageIO library for Python and deal with things that way. But yeah, are there any last questions? I didn't go through maybe too much about other things in Matplotlib, but I guess maybe there was a few things that were useful here. And let's see, anything here in Slack? Yeah. Okay. I can't tell how far ahead I am, but I'm guessing that maybe there aren't any big questions. And like before, what I can do is I'll put this this little thing that we did with the different color plot points and the different plt.scatter versus plt.plot up on the GitHub page with these silly, notebooks from the Geo-Python streams. And otherwise, I guess if there are other questions, then we can deal with that stuff maybe in Slack. I think there was one person who had asked a question about having a problem on exercise 7, and I haven't answered that yet, but I can try to do that later today. If there's not any other questions, then I think that's it for today, and I think that might be kind of it for these streams, unless there's a need for another one. My kind of impression was that you guys are you've been told to basically wrap it up by the 14th. So I think I'm available next week if needed for a stream. If there's not a strong interest in that, then I would also be okay with just skipping it. But maybe I'll leave it in Slack for you guys to decide if you think a stream would be helpful or necessary. And if there's specific things you want to talk about, then that's all the better, because I've kind of covered some general stuff in Python plotting. So yeah, I'll add a post in Slack, and if there's enough interest, then we can run a stream again next week. If not, I hope the course has been useful, and I hope that the materials have generally been fairly self-explanatory. It's not necessarily that easy to do the course when you're just reading the web page. So I think that we've put a fair amount of effort in trying to make sure that the course materials are easily accessible to anybody who sits down to take a look at the course. But I hope that's been your experience, that it was easy to work with, and I hope that you'll continue using the little bit of Python that you now know to use that as a basis to explore a bit more and to learn more about the Python programming language. Google is your friend when it comes to this stuff. There's a huge amount of information you can find online about Python coding examples and how to do more complicated things than we cover in the course. If you just look around, and I think I've learned a lot about what I know of Python from basically just looking in Google and seeing how different people do things and taking the things that make sense to me and sticking with them. So with that, I'll just say good luck, and if you've got any other questions about the stuff for next week, perhaps we can have one more session like this. But otherwise, again, I hope you've enjoyed the course, and I hope that you'll continue using Python after this. So that's it for this week, and we'll see you about next week. All right, thanks.